Hi, this is Exceptions and Error Handling. My name is Chris Lee and my student number is S224817878. Just for a bit of an overview today of some of the things that we're going to be covering, we're going to be talking about exceptions. Now, exceptions occur when a program fails to do what it was designed to do. This might be because of the program logic or some poor input or something or other. The two main sort of types that we were learning in this task were the runtime exceptions and the application exceptions. For the runtime exceptions, these are sort of system level exceptions. So things like the out of memory exception or divide by zero are examples of those. They're typically not recoverable. The application exceptions are probably more common. That's going to be something like poor input. So whether you get, say, invalid input or an argument out of range or something or other, that's typically when you'll encounter these. Now, they are recoverable. You would just have to determine how you want to handle it, whether you want to reprompt for the correct input or whatever. Regardless, in any event, the specific exception that I'm covering today is the out of memory exception. We're going to do a code review and then we're going to review the Windows Event Viewer logs. Okay, so for the out of memory exception, this exception typically occurs when the CLR is attempting to allocate memory for a new object, but it can't because we have insufficient memory. This is a runtime exception, so this is going to be an issue with our system itself. So we're going to have insufficient memory and the program's going to crash. It's not going to be recoverable, or not typically, at least anyway. I mean, even if you do try to catch it, you're probably going to notice some unexpected behavior. This could sort of occur for a few reasons. Like one of them would be that the CLR and the garbage collector themselves need memory to run. So if this exception is thrown while they're in an invalid state, that could generate some unexpected behavior. Another one is the application state itself. Say we had a process that was in the middle of executing when this exception occurred, we would have a problem there. It might not be able to roll back and stuff like that. So for us in particular, with the code itself specifically, we have a try-catch block. And the basic premise of this is that we're going to create a list, and the list is going to store byte arrays. The byte arrays are going to be 100 megabytes and 0 initialized. We have a count, and I'm using the count to sort of track how many arrays we can add before we run out of memory. It'll do this in an infinite while loop. We're using the add method here. So test list is going to be allocated on the heap, and that is going to store references to these arrays, but the arrays themselves are going to be allocated individually. Now, because of the way that arrays store data, which is sequentially, so it's neighboring bytes, we're going to need contiguous memory, and eventually we're going to reach a point where we just don't have any contiguous memory left, and the program's going to crash. When it does, I'm using the failfast method. There's a few reasons for this. The first is that it's just going to bypass any crashes and just crash the application. Bypass any failures and just crash the application immediately. And when it does, it's going to write some information to the Windows Event Viewer logs, and that's something that we'll review. For me personally, I've historically, at least anyway, been able to get about 472 to 481 arrays added before I run out of memory. This is personal to my system. Your mileage may vary. In any event, we'll run it a few times and we'll see what we get. There we go. So for this particular example, I got 509 before we threw a out of memory exception. And just as a side note, with these exceptions as well, when it comes to your application logic, there's a couple of ways you can go about it. You could signal an exception yourself manually using the throw keyword and then just providing some instance of the system exception class, or you could opt to have your program logic proc it naturally, which is sort of something that I've done here and what we just saw. I'll run it one more time for good measure. If I would run that again, we've got memory to spare today. All right, so now that this has all sort of happened, we're going to review the event logs. I have 3 that I was playing around with earlier. So we can see date and timestamps on them. when you're sort of reviewing these logs anyway, you get a general sort of description. So we can see that Windows has diagnosed a low virtual memory condition, and it'll list some processes. I prefer looking at the details, that tab. And within this sort of pane, we can see the processes that were running when we ran out of memory. The first process was the exceptions and error handling executable. Now this is my program itself. That program was running inside of the dev-env executable. Now that executable is the Visual Studio executable, and the final process that was running is the ScreenPub, which is my sort of screen recording software. Now, in terms of sort of events, or exceptions I should say rather, this is not going to be a very typical one. You would design your application to avoid a scenario like this rather than trying to catch it or handle it or anything like that. The more popular ones are probably going to be the application exceptions with invalid inputs and stuff like that. I just personally found this one a little bit more interesting, so I've decided to talk about this one. Thank you.